Next, we're going to create the Docker file needed for our project. So in the project file navigation here, we're going to create a new file in the root of the project. We're going to call it Dockerfile. Then we're going to define the steps that Docker needs in order to build our image. So the first step is to define the name of the image that we're going to be using. So that's the base image that we're going to pull from Docker Hub that we're going to build on top of to add the dependencies that we need for our project. So we do that by typing from and then the name of the image. So we'll be using Python :3.9 Alpine 3.13. Now I'm specifying the specific version of Python and the version of Alpine that we're using because I want to make sure that the steps are the same when you follow the course as they are when I recorded these videos. So I recommend you use this specific version. You can find the different versions if you head over to the browser and you go to hub.docker.com. Once you're on that page, there's a search functionality where you can search through all of the base images. So if you search for Python, you should see the official Python image here, and it will have a list of all the different image tags that are available. The one that we're using is the Alpine image tag for version 3.9. So Python is the name of the Docker image that is on Docker Hub. 3.9-Alpine 3.13 is the name of the tag that we're going to be using. And what this does is it ensures that we are using Python 3.9 and we're using the Alpine version. So Alpine is a lightweight version of Linux and it's ideal for running Docker containers because it is very stripped back. It doesn't have any unnecessary dependencies that you wouldn't need. Everything that it comes with is just the bare minimum, and it's an extremely lightweight and efficient image to use for Docker. So that's why I like to use the Alpine image. Next, we define the maintainer. So we set label maintainer equals, and then you can specify your name or the name of the website, just basically whoever's going to be maintaining this Docker image. And it's best practice to define this. So if other people work on the project, they know who the maintainer is. So I'm just going to put my website, londonappdeveloper.com. Then we're going to specify env and all uppercase caps Python unbuffered _1. And this is recommended when you are running Python in a Docker container. What it does, it tells Python that you don't want to buffer the output. The output from Python will be printed directly to the console, which prevents any delays of messages getting from our Python running application to the screen. So we can see the logs immediately in the screen as they're running. Next, we'll type copy dot / and then lowercase requirements.txt / tmp / requirements.txt. And then below that, we're going to type copy dot / app / app, and then work dir / app, and then expose 80000. So what this block does is it says copy our requirements.txt file from our local machine to /tmp / requirements.txt. And this copies the requirements file that we added earlier into the Docker image. We can then use that to install the Python requirements in a moment. Then what we do is we copy the app directory, which we're going to create in a moment, and that's the directory that's going to contain our Django app, and we copy it to /app inside the container. Next, we set the work dir. So the work dir is the working directory, and it's the default directory that all commands are going to be run from when we run commands on our Docker image. And basically we're setting it to the location where our Django project is going to be synced to, so that when we run the commands, we don't need to specify the full path of the Django management command. It will automatically be running from the /app directory. Next, we set expose 8000, which says we want to expose port 8000 from our container to our machine when we run the container. And what this does is it allows us to access that port on the container that's running from our image. And this way we can connect to the Django development server. Next, we're going to add a run command that is going to install some dependencies on our machine. So I'm going to type out the full command, and then I'm going to explain line by line what each line does. So we'll type run python -m venv /py && backslash, and then an indentation under that we'll do /pi/bin/pip install --upgrade pip double & sign backslash /py/bin/pip install -r/tmp/requirements.txt double & sign backslash rm-rf/tmp and then double & sign backslash add user, so add user backslash, and then another indentation of that, do -- disabled -password backslash -no -create -home backslash, and then Django -user. Then under that we're going to type env path equals, and then in quotes /pi/bin, and then colon $path, and then finally the last line we're going to add is user Django-user. Okay, so what this does is we run the run command. So this runs a command on the Alpine image that we are using when we're building our image. So I've broken the commands down onto one run block. So you could technically specify run and then each one of these lines individually. However, what happens in that case is it creates a new image layer for every single command that we run. And we want to avoid doing that to keep our images lightweight as possible. So what we do is we specify a single run command and we break it down onto multiple lines using this &/ syntax. So it looks a little bit confusing, but it does make the building of our images a bit more efficient because it doesn't create so many layers on our system. The first command we run is python-m venv /py. This creates a new virtual environment that we're going to use to store our dependencies. Now, lots of people have conflicting opinions on this. Some people think that you don't need to use a virtual environment when you're working with Docker, and this is probably the case in most cases. However, there may be some edge cases where there are some Python dependencies on the actual base image that might conflict with your Python dependencies for your project. So the way to avoid this happening and to reduce any risk, you can create a virtual environment in the Docker image, and it doesn't really add that much overhead, so there's not really that much downside to it, but it just safeguards against any conflicting dependencies that may come in the base image that you're using. So this is why I like to use virtual environments inside Docker images. The next command we run is we're specifying the full path of our virtual environment. So we want to upgrade pip for the virtual environment that we just created. So we specify the full path by doing /py/bin/pip install upgrade pip. So this upgrades the Python package manager inside our virtual environment. Next, we install our requirements file. So this /tmp/requirements is what we copied here on line 6. And basically, we install that list of requirements inside the Docker image. So this will install it inside our virtual environment because we're specifying the full path to pip inside our virtual environment, /py/bin/pip. Then we remove the tmp directory. The reason we do this is because we don't want any extra dependencies on our image once it's been created. It's best practice to keep Docker images as lightweight as possible. So if there are any files that you don't need on the actual image, you want to make sure they're removed as part of your build process. So any file you just need temporarily, you add it, use it inside the Dockerfile, and then remove it before the end of the Dockerfile. And this just helps make sure that the Docker image is as lightweight as possible, so it saves a lot of space and speed when you're deploying your application. Then we have this add user block here. So what this does is it calls the add user command, which adds a new user inside our image. So the reason we do this is because it's best practice not to use the root user. If we didn't specify this bit here, then the only user available inside the Alpine image that we're using would be the root user. The root user is the user that has the full access and permissions to do everything on the server. So anything that you can do can be done by the root user. There's no restrictions or limitations. It's not recommended that you run your application using the root user, because this means that if your application gets compromised, then the attacker may have full access to everything on that Docker container. However, if you run your application using a user that doesn't have full privileges, then that means if your application does get compromised, the attacker will only be able to do what that limited user can do. So that might just be accessing the code, and it's still not good that it's been compromised, but at least they don't have full access to everything in that container. So that's why we do add user. We're specifying disable password because we're not going to be using a password to log on to this. We don't want people to be able to log on to our container using a password. We just want to do it by default when we run the application, use that user. We do no create home, so it doesn't create a home directory for that user because again, it's not necessary and we want to keep the Docker image as lightweight as possible. Finally, we specify the name of the user. So we're just going to call it Django-user. You could call it app. You can basically call it whatever you want. I'm using Django-user just so we explicitly know what that user's for in the container. Now we have the env line. So this updates the environment variable inside the image, and we're updating the path environment variable. So the path is the environment variable that's automatically created on Linux operating systems. And what it does is it defines all of the directories where executables can be run. So when we run any command in our project, we don't want to have to specify the full path of our virtual environment. So we don't want to specify /pi/bin every time. So the way we can avoid that is we can add this line here, which will add /pi/bin to the system path. So whenever we run any Python commands, it will run automatically from our virtual environment. Finally, we have the user line, which should be the last line of our Dockerfile. And this specifies the user that we're switching to. So until we run this line here, everything else has been done as the root user. And the containers that are made out of this image will run using the last user that the image switched to. So because we are switching to user Django user, anytime that you run something from this Docker image, it's going to run as the Django user. So it's not going to have that full root privileges that we need for setting up the Docker image. So that's everything we need to do to create the Dockerfile. Now save the file, and next we're going to add a Docker ignore file. So in the root of the project, create a new file and call it dot. It's very important you add the dot at the beginning. Docker ignore. And you need to make sure that you spell this correctly, otherwise it's not going to get picked up. And what this is it allows us to specify a list of files that are going to be excluded from the Docker context. So when you run the Docker image, it uses something called the Docker context, which is the directory that you're running from. And all of the files are passed into the context, except for the files that you list in Docker ignore. So basically in this file, we want to exclude any files that Docker doesn't need to be concerned with. So that's files we want to exclude from our Dockerfile and from whenever we run our Docker commands. So I'm going to manually list out each of the items here. There is a link in the resources of this video to the code snippet. So feel free to copy and paste this. It's kind of a standard file that most people use, but I'm going to type it out line by line, and then I'm going to explain what each line is for. So we'll do a comment here at the top, git. We'll ignore .git, lowercase, and then .git ignore. And then we'll add another comment here, docker. We'll add .docker, and then we'll add another comment here, Python. I'm going to add app / ___ pi cache __/. And then I'm going to copy this line, and I'm going to do app / and then wildcard. And I'm going to do this a few times here, and I'll explain why we do that in a minute. So, and then I'll do 2 more here. There we go. And then I'm going to do .env / and then .venv / and then venv /. Okay, now save the file. So the top 2 are Git files and directories. So .git is a hidden directory for Git. We don't need that copied into our Dockerfile, and that can actually be quite huge because it contains all the Git history. So we exclude that in the Dockerfile. We'll also exclude the git ignore because we don't need that inside our Docker file. And then we exclude .docker, which is a Docker hidden file that might be created in our project that doesn't need to be used by our actual Docker file. So it just contains some Docker working files that are used specifically on our local machine. They don't need to be copied into our Docker image when we build it. Then we have Python. So these are the Python exclusions here. When you run Python code, it creates a cache and it puts that inside PyCache. This isn't needed on our Docker container, and in fact it can actually create problems if it does, because the PyCache that would be created on our local machine would maybe be specifically for our operating system and not for the Alpine operating system. So we just exclude them from the context just to make building our container a bit faster. The reason why I do this asterisk here is just to make sure that all of the different PyCache files may be removed. Unfortunately, the Docker ignore file doesn't support things like doing a double asterisk to do all subdirectories. So you need to specify each subdirectory individually, which is what I've done here. Then we remove .env, .venv, and just venv without the dot. And this is the virtual environment. So we want to remove any virtual environments that we may create locally in our project from the context, because they don't need to be copied over. We already have a virtual environment that we add in our Docker file. So make sure you save the file. And now let's go ahead and test building our image. So if you load up the terminal, or if you're on Windows, you're going to use either the command prompt or the git bash window. We're going to type docker build dot. This runs a command for building our Docker image, and we'll see if there are any failures when in our Docker file. So you can see here we got a failure because it couldn't copy the app directory, and that's because we didn't create the empty directory. Because we have this line here where we copy an app, which we're going to be adding our Django project to eventually, the build of the image fails. So all we need to do is create a new folder in the root of our project called app, then head back to terminal or git bash, run the command again, and this time hopefully it should work. What happens is it goes through each of the steps that we define inside our Docker file, and it will run that to create an image. And it uses caching behind the scenes, so the first time you run it, it might take a while, a few minutes for it to download any dependencies and to build our image. However, the second time you run it, it should be a lot faster because it caches each layer that is needed to build our Docker image. We'll wait for that to finish and then we'll continue. Okay, so you can see that built successfully. So we've successfully configured a Dockerfile for our project. Now we can move on to the next lesson.